All right, so we'll finish this problem up. Example number 29, we have our two equations, and so we're just going to go ahead and solve. So one of the things that we could do is we could solve it by elimination. So I could multiply this one through by negative 28, or this one through by, or by negative 43 to eliminate the x's or the y's, whichever one we want to do. Let's go ahead and multiply it by a negative 28. So I'm going to get a negative 28x, and then a negative 28y, and then that equals, and we have 28 times 5, and 28 times 5 is going to give us 140, and oops, that one's 140, 28 times 5, and then we have those two extra zeros, and not three extra zeros, two extra zeros. And so now what we have is the difference between these two, because this is a negative, and we have 0 here, and 43 minus 28. So 43 minus 28 is going to give us a 15, and that's 15y, it's positive. And then we have the difference here, 5 minus 0 is 5, 0 minus 0 is 0, 8 minus 0 is 8, and 16 minus 14 is 2. And then we're going to multiply by the reciprocal here, and finally we'll come up with what y is equal to. So 2,805 divided by 15, and we get 187 from there. Now remember that we have all those tricks that I was talking about the other day in class. If we don't have a calculator on us, we can say, oh, I know these are both divisible by 5, so I could take out the 5 here, and 5 will go into this one 3 times, and 5 will go into 28 5 times, 3 left over 6 times, and 1 time. And then we say, okay, can we divide this by 3 will go into 5 1 time with 2 left over, 26 8 times with 2 left over, and 7 times, and there we see it. So now we know that this is 187 187 people for the adults, or 187 adult tickets, and then we can do 500 minus that in order to give us the number of seniors. So 500 minus 187, and so we have 10 minus 7, which is 3, and 49 minus 18, we have 1, and that should be 313. Let's see, let me make sure that I did that mostly in my head. It was correct, yep, 313. So those would be our numbers there, and we would use seniors and adults to say that. We wouldn't want to just leave those hanging. I'm not going to write that out just because it's going to take me more time than I want to take right this instant. Okay, moving on to our next problem. Let's scroll down here and look at example number 30. So example number 30, again, we're going to start out with a table. And in this scenario, we're going to have two different scenarios, right, plus a grand total here. And we're going to have one column for the independent, one column for the rate of change, and another column for the total value. So we have to read our problem in order to get those, and I'm going to go ahead and read it out and see if you can put it together, and then we'll come back and see how it went for you in the next one. So Sal's coin collection of dimes and quarters is worth $15.25. There are 103 coins in all. How many of each are there? Now this one might seem a little tricky because it may seem that you don't have enough information, but you're coming to this problem with a lot of information. So I'm just going to give you a hint. We have the number of coins, right? Number of coins, and then what we're dealing with is the dollars per coin, and you can put those in dollars or in cents, it's up to you. And we have two different types. We have dimes and we have quarters. And so why don't you guys go ahead and see if you can finish it off, and then come back in the next video and check your work. So quarters here, and then totals down here, and this is a total value over here. So this is a total, and total values, I always use total dollars, right, for total values. Multiply here, and this is a grand total down here. See you in the next video.